In this video, we're going to take a look at the Model Mania Design Challenge from 2013. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where attendees are given a drawing like this, and they're tasked with creating the part in SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't enough, when they're finished, they're given an additional drawing with a series of changes and tasks to perform on the part. For this initial phase 1, though, let's take a look at how we'll approach this. Most of the geometry and dimensions are defined in the top view. It's actually a pretty simple part to create. It consists of 3 circles with bores going through them and a series of walls joining them together. You can see in the front view in section AA that these are all extruded slightly different depths in the up direction. Finally, do notice that a material has been specified over in the notes section of this drawing. So let's dive in and let's start with that top view. We're going to leverage a sketch that contains all the geometry and use contour selection when we go ahead and create the features for this part. We've discussed this in great detail in many of the videos in this series. So I'm going to go ahead and just start sketching out this geometry by typing in the values where needed. In this case, it's just a series of circles which have pretty simple dimensions on them. 15, 20, and then you can see I've already defined some of the other dimensions. These are then defined by distances from the center. In this case, 22 millimeters to the right, and down from the top, this is going to be 36 millimeters. Notice the geometry turns black, letting us know that it's fully defined. Let's go ahead and define this circle out here to the right-hand side at 70 millimeters away, and notice when I add that dimension that the geometry is still blue. That's because we didn't do anything to establish that this circle is always horizontal to this one. So I'm going to select the 2 center points and choose horizontal from the quick pop-up menu. So that's all fully defined. There's also a series of arcs that joins this together. I'm going to do this by creating 3-point arcs from one circle to the next and approximately drawing it in place. So we can also put the radius in there while we're creating this if we want, so just by typing that. So again, this is 80 millimeters. But notice when I do this, notice what's happened. None of these were created tangent to the circles that they're attached to. So we're going to go back and we're going to add those tangency relationships at each one of those intersections between these. So I'm going to just go ahead and window select those, and we didn't add a radius here, so I'll add that now. And again, let's just add these tangencies. And I'm going to just move these radius dimensions so that they're a little bit easier to see. Now notice I did define each one of those individually. That's how they were called out on the drawing. And the last thing we need to do is I'm going to go ahead and do this wall offset while we're at this too of 3 millimeters. So I'm going to select any geometry that I want to add in this case, and notice when I select all of these, I just go ahead and right click and add the geometry like so. Sometimes they may offset in a different direction depending on the order in which you created those, but in this case we were able to do that all with one offset feature. Now you're probably thinking I'll need to go through and trim all this geometry up, but that's actually not necessary. Let's go ahead and close this sketch and start creating some of these extrusions. I'm going to go ahead and select this circle, and notice what happens when I do this. I'm going to specify the appropriate distance. It created the region up to there. All I need to do is select this additional region. In addition, if you want to make this simple, just go ahead and select the circle itself and then choose the circle in the center to then remove that from that region. So there's really 2 different approaches you can take when doing this. I'm going to go ahead and press OK. When I do this, you'll notice that a solid bodies folder appears in the feature manager tree. Because these bodies are disjointed, we're actually working in a multi-body part file. That's actually not that important for what we're doing right now, but it will play a role in what we're doing later on with some of the changes. Now what I want to do is start joining this back together. In this case, I want to create the walls on the outside. To do this, I'm just going to go into the feature manager tree and reselect that sketch we created and choose to create an extrusion from it again. And like before, I'm just going to choose the appropriate regions that I want. In this case, the 3 outside wall regions. Now their distance is different. It's 12 millimeters, so I'll enter that in. And notice that merge results is automatically checked. This is always the case by default. In addition, the feature scope by default will try to merge whatever it can. In this case, it will end up being all 3 bodies. When I do that, the multi-bodies folder goes away. So adding that feature joined those back together into a single body part. Finally, for the material on the bottom, you guessed it, we're going to go back in and choose that same sketch, and we're just going to select the regions on the inside. Again, they do have a different depth, in this case 3 millimeters. Finally, there's a series of 1.5 millimeter fillets that we want to add, and to do this, I'm going to select these faces on the inside of these pockets. Remember, selecting faces allows you to just select that face, and then it'll automatically capture all the edges of that face, and because of tangent propagation, any additional edges that might be tangent. We'll do the same thing on the other side. I'm going to go ahead and grab these 3 faces here, and then I'm just going to right click to confirm. So our part's almost done, but there's one critical feature we need to add yet, and that's the material that was defined for this part, which was plain carbon steel. To do this, we simply right-click on the material node in the Feature Manager tree. If the material you need is in your favorites, you can select it here. If it's not, you can go into the entire library that's available. When you're working with a library, just choose the appropriate material type, in this case steel, find the material you're looking for, and SOLIDWORKS will automatically apply the appropriate appearance and crosshatch in a drawing, but more importantly, the physical properties of the material, which define how strong it is, as well as things such as its density. So I've gone ahead and applied the material. When I exit, you can see that it's graphically changed, but if I go to Evaluate and go to Mass Properties, we also get an accurate weight of this part as well. So we've created phase 1. At this point, we would get an additional drawing for phase 2. When we look at the phase 2 drawing, there's several changes that have been made to those original cylindrical bosses we created. Clearly seen in the front view in section AA, we can see that the center one has been shifted down 4 millimeters, and the outside right cylindrical body has been shifted down 8 millimeters. In addition, notice in this section view that the bottom surface that we had created is no longer there and instead has been added as a top surface. Finally, there have been some subtle changes made to the fillets. Additionally, we do need to perform a simulation on this part by fixing the center cylindrical face and applying a load to the outside right face. So let's go into SOLIDWORKS and look at how we can tackle this. Let's start with the design changes themselves. First, we want to make those adjustments to those cylindrical bodies. I'm going to go ahead and roll my rollback bar back to when we created these 3 cylindrical bodies. If you remember, I made a specific point to mention that we were working with multi-body at this point. This is great because it allows us to, instead of deleting features and adding new ones and applying offsets, we can just do a quick search in our command search for the Move Copy Bodies command. Likewise, you could have it on your toolbar already. I just don't. Then we can select each body and just make a quick adjustment to it. In this case, this one is moved down 4 millimeters. So notice I just grab the arrow, drag it down, snap it to the ruler, and press OK. But I had mentioned, what if this was a single body? Move bodies will move the entire body. Move face, oops, not intersect, let me hit escape out of there. Move face is an alternative where you can grab the faces you want to move very similarly. And in this case, I'm going to use Move Face to drag this down 8 millimeters in this case. So we've dropped that down. That looks good. We press OK. We get the same results, just one is a little bit easier to use. Move Bodies would be easier when you're working in multi-body. Move Face is great if everything's joined together and you want to just move a few faces. So keep that in mind. We're then going to go ahead and roll down, and notice that our walls don't really have any changes that need to take place to one another. However, when we do look at our next feature, that bottom surface, it no longer exists on this left-hand side of the part, and instead there's a new surface up here at the top. So what we're going to go ahead and do is just edit this feature, and I'm going to deselect this region to exclude it. Then I'm going to go into that feature and reselect that initial sketch, and I'm going to choose to create an extrusion using that same region. Now we want to get the extrusion here just right. An easy way to do this is with the From option. I'm going to choose From Vertex, and I'm going to go ahead and choose a vertex up at the top. We're going to then use the direction of blind and set that down into the part. And very quickly, we've just gone and made that adjustment that way. Now, because we did delete that bottom surface face, some of the faces we selected for this fillet no longer exist, and they'll need to be redefined. So we're just going to simply come in here and reselect those. Additionally, You might notice on the drawing that these additional edges have been added to the fillets. This is one of the things when you actually do Model Mania, when we mention check for accuracy. Missing a fillet like that could be the difference between winning and losing the competition. Now you'll notice that those faces that are no longer there are still highlighted. You could delete them out of the property manager here, but simply pressing OK, SOLIDWORKS will let us know that there are some missing entities. Pressing yes will automatically remove these, so kind of saves us that step there. So we've made all the physical changes to the part here pretty easily using a few unique features: move copy bodies and move face. What we need to do now is perform a simulation. And to do this, I'm just going to go ahead and use Simulation Express because it's found in every version of SOLIDWORKS. Likewise, you could use SOLIDWORKS Simulation, which provides many more options than what we'll see here. Simulation Express is a wizard's format that kind of walks you through the process. The first thing we need to do is define a fixture. In Simulation Express, we can only add a fixed type fixture. If we were using simulation, we could use things such as a hinged fixture or sliding face, different things like that. But this serves our needs perfectly in this case. We're going to choose that inside cylindrical body and press OK. We could add more if we wanted to at this point, but let's move on to adding a force. Here we have the choice between a force or a pressure. Again, in SOLIDWORKS Simulation, you could add different types of forces. In this case, we're going to go ahead and just apply a force to this outside cylindrical face. Notice the direction of the arrows, however, and on the drawing, the load direction is pointing straight down. So we need to fix this in here by changing to using the selected direction option. We then need to choose some form of reference geometry. Conveniently, our front plane is normal to the direction we want to apply that force, so we'll simply choose that, and then we'll enter the load down here of 500 newtons. We'll then go ahead and press OK. Again, we could add more forces if we wanted, but we don't need to. And here we would have an opportunity to specify the material should we or had we not done that before. Notice because we did it before, it automatically captures a lot of the important information that we need. So specifying the material is really important because it's not just used for the looks of the part, the weight, or the cross section, but it's also used in simulation. Then all we need to do is choose to run the simulation, and really quickly SOLIDWORKS will come back with a series of results letting us know how those forces act on the part. We need to just verify, is this what we anticipated? Yes. If it wasn't, we could go back and make some changes. And then instantly we're given results. Notice here it gives us the lowest factor of safety on our part, 3.09189. It may be some variance in there based on how tightly it was meshed automatically. But one of the things I really like here is we could actually look for weak spots in the design by entering an extremely high factor of safety and finding spots in our design that are lower than that. Additionally, we could also show the displacement on the part in this case. Here, we see this in scientific notation, but again, if we were using SOLIDWORKS Simulation, we could customize this all we want. For example, using a floating point decimal. So there you have it. We've done the Model Mania Design Challenge from 2013. We made several changes to it and even performed a simulation at the end. If you're interested in learning more about Model Mania, or more specifically SOLIDWORKS World, I invite you to check out the links below this video in YouTube or any of the links on the blog post where this is hosted.